Hello everyone and thanks for stopping by once again. This is Paragon Pathfinders and on this platform we take stress out of learning science. In today's interesting video, I'll be showing you how to prove these trig identities before us. These are either trigonometric identities or expressions and they look very complicated and difficult, but trust me, they're not hard. They're really easy and straightforward to prove. Now, how do we do that? Before we go ahead to solve this interesting question before us, I need you to understand this. And it's a tip for you whenever you're proving trigonometric expressions or identities. Whenever you're working on such problems, make sure you understand that it's easier to work with sine and cosine than with every other expression. For example, it's easier for you to manipulate cosine and sine than to work with secant, cosecant, or tan. It's quite easier for you to manipulate sine and cos than for the other ones. And it's a tip for you. So whenever you're working on solving these problems or whenever you're solving these problems, it's always easier for you to work with sine and cosine. All right, let's go ahead and solve this very problem. And I'm going to start from the first one. Let me clean the second one. Let's go ahead and prove that the right part is equal to the left. Whenever you're proving trig identities, always make sure you start from the more complicated part. Do not start from the easier part. Otherwise, ending at the more complicated part is going to be quite cumbersome for you and almost impossible unless you have an advanced skill in math. In this case, we're going to start proving from the right and show that it is equal to what we have on the left. I'm going to write my proof, right-hand side. I'm writing the right-hand side because that's what I'm starting with. Now I'm going to go ahead and copy everything here down. We have tan alpha plus tan beta over 1 minus tan alpha multiplying tan beta. Whenever you're proving trig identities or simplifying trigonometric expressions, you need to know and understand that it's easier to work with sine and cosine than with secant, tan, or cosecant. Therefore, we need to know that tan alpha is equal to, this is a quotient identity that is equal to sine alpha over cos alpha, right? This is a quotient identity. So this tan here is equal to sine over cos. And because it's easier to work with, that is, it's easier to work with sine over cos, we're going to convert everything here to sine over cos. The tan alpha will be converted to sine over cos alpha, and the tan beta will be converted to sine beta over cos beta. For simplicity's sake, and in a way, it's going to be quite easier for us to manipulate. I'm going to copy this down here. We're going to have sine alpha. I'm now replacing the tan alpha with sine alpha over cos alpha plus the tan beta would now be transformed into sine beta over cos beta. And for the denominator, we have 1 minus. For the tan here, we know that tan alpha is equal to sine alpha over cos alpha. Therefore, we're going to replace the tan with the sine alpha over cos alpha, multiplying the next one, which is tan beta, and we shall obtain sine beta over cos beta. At this point, we are not done yet. We've seen that we have two fractions. We have one at the numerator and the next one at the denominator. What do we do in this very case? Whenever you're working on trigonometric expressions and you obtain fractions, your next task should be, how do I combine them into a single fraction? And in this case, we have cos alpha and cos beta as their denominators. And the next one, we have cos alpha and cos beta as well as its denominator. Now, what do? Our goal is to combine them. They are not the same. Therefore, we can just say, let's pick one denominator. We're going to work on them and make the denominators the same. I'm going to draw a line here so that we can continue from here. I'm going to, first of all, work on my numerator. I'll have to solve them separately for simplicity's sake. Remember, I told you, whenever you're proving trig identities, whenever you're simplifying trigonometric expressions, make sure you convert everything, if possible, to sine and cos for our simplicity's sake, because they are easier to work with. They're also easier to manipulate. Now, I'm going to copy the numerator here and simplify it first. When I'm done with the numerator, I'll copy the denominator and also simplify, then combine the two of them together. Here we have sine alpha, and beneath we have over cos alpha plus sine beta over cos beta over cos beta. How do we combine them now as a single fraction? Well, I would love to think about it this way. You multiply them diagonally. Multiply them diagonally. It's easier to understand it this way, where the denominator of the right multiplies everything on the left. The cos beta on the right is going to multiply the sine alpha on the left and the cos alpha on the right, while the cos alpha on the left is going to multiply the numerator of the right and the denominator as well. That's how to do it, to combine them as a single fraction. Let's go ahead and do just that. Therefore, we shall obtain, if you multiply cos beta and sine alpha, you shall obtain sine alpha cos beta over, here you shall have cos beta times cos alpha will give you cos beta cos alpha. Okay, and for the next one, or we can also say cos alpha cos beta. It does not really matter. I think it's better I say cos alpha cos beta. So cos beta multiplied by cos alpha will give you cos alpha cos beta. And on the right part, if we do this multiplication, what are we going to obtain? Cos alpha multiplied by sine beta will give you cos alpha sine beta over, for the next one, we have cos alpha cos beta. Okay, like I said earlier, whenever you have a fraction like this, just multiply the numerator and denominator of the left with the denominator of the right. Okay, and everything on the right shall be multiplied by the denominator of the left. And with that, you'll get the common denominator, thereby making it easy for you to combine them as a single fraction. Let's continue our work up here. I'm going to combine them right now because we have a common denominator, which is cos alpha cos beta, cos alpha cos beta. Let's combine them. Here we have sine alpha cos beta plus cos alpha sine beta over the denominator, which is cos alpha cos beta. Now we're done with the numerator, which is what we had initially here. I've transformed sine alpha over cos alpha plus sine beta over cos beta into this. This is the transformation of this. Now, we are done with the numerator. Let's go ahead and work on the denominator, which is 1 minus sine alpha over cos alpha times sine beta over cos beta. This is our denominator. I'm going to copy this. We have 1 minus sine alpha over cos alpha times sine beta over cos beta over cos beta. Let's go ahead and combine this. First, we need to multiply them together because this is a multiplication just like a times. We're multiplying them. Let's ignore the 1 for now. We copy it down minus sine alpha times sine beta. Remember, if you have a fraction like this, all you need to do is to multiply the numerators together and denominators together as well. Sine alpha times sine beta would give you sine alpha sine beta over their denominators. Cos alpha times cos beta would give you cos alpha cos beta. We're not done yet. This one can be written as 1 over 1. 1 divided by itself, or 1 divided by 1 is also 1. But this is going to be easier to work with so that we can multiply diagonally and combine them as a single fraction. Now, let's multiply diagonally. Remember what I told you initially here. If you have something like this, you just multiply diagonally. In this case, we're going to multiply everything on the left by the denominator of the right, and everything on the right by the denominator on the left, or of the left rather. Therefore, this is now going to be cos alpha cos beta times 1 will give us cos alpha cos beta over cos alpha cos beta times 1 again will give us cos alpha cos beta minus, remember there is a negative sign here. Now let's multiply across again. 1 times sine alpha times sine beta will give us sine alpha sine beta over 1 multiplied by cos alpha cos beta will give us cos alpha cos beta. We've now seen that the denominators are now looking alike. Therefore, we can go ahead and combine them. They are now cos alpha cos beta, and on the right we have cos alpha cos beta. Let's combine them. We shall now obtain cos alpha cos beta minus sine alpha sine beta over their denominator, which is cos alpha cos beta. Okay, so this is our denominator, which is this. This value here, or this expression here, is a transformation of this. Our numerator has been transformed to this, and our denominator has also been transformed to this. Therefore, we can now combine them together and simplify. Please permit me to clean this part so that I can continue working right here. I'm going to combine them together at this point for easier simplification. We have our numerator, which is sine alpha cos beta plus cos alpha sine beta over cos alpha cos beta. Remember that they are dividing themselves. Therefore, I'm going to put a division sign here and now copy this one and bring it here. Because this one divides, this is the denominator, and it's dividing the numerator. This is now going to be cos alpha cos beta minus, I'm going to clean this part so that we have enough space for our work, minus sine alpha sine beta over the denominator, which is cos alpha cos beta. Next up, what do? We take the reciprocal of the denominator. Whenever you have a division sign, to change it to multiplication for simplicity, all you need to do is to flip the term on the right, which is the denominator. Flip the denominator. This is actually the denominator, but for simplicity's sake, we put it on the right and put the division sign so that it's also dividing. That is, this one here is dividing the one on the left. So taking the reciprocal simply means that we're going to flip it, the one on the denominator now goes to the numerator and the numerator goes to the denominator. That's how to take the reciprocal. This is now going to be sine alpha cos beta plus cos alpha sine beta over cos alpha cos beta times cos alpha cos beta over, remember we flipped it, or we flipped them, the denominator now becomes the numerator and the numerator goes to the denominator. We have cos alpha cos beta minus sine alpha sine beta. At this point, we've seen that we have cos alpha cos beta on the denominator of the left and cos alpha cos beta on the numerator of the right. Therefore, they can easily cancel out. They can cancel out. And if they cancel out, we have a 1 here and we also have a 1 here. What do we do at this juncture? We can now multiply across. Sine alpha cos beta plus cos alpha sine beta multiplied by 1 will give us the same value, and the denominator multiplied by 1 will also give us the same value. Therefore, we're going to obtain, if we do the multiplication, we shall have sine alpha cos beta. Okay, I think we don't have enough space here. We shall obtain sine alpha cos beta plus cos alpha sine beta over the next one here, which is cos alpha cos beta minus sine alpha sine beta. This is where we have reached in the simplification of what we have on the right. And it's really easy to get stuck at this point if you're not conversant with all these trigonometric identities, which I told you that you need to have at heart. Well, here we've seen that we have sine alpha cos beta plus cos alpha sine beta. This is a sum and difference formula. It's an identity. And if we have sine alpha cos beta plus cos alpha sine beta, this is an identity. This is an identity that is called sum and difference formula. This is equal to sine alpha in bracket plus beta. This is a sum and difference formula which you need to know if you want to prove trig identities. Therefore, since this sine alpha cos beta plus cos alpha sine beta is the same with this and it is equal to this, we're going to replace all this expression with this. That's the next thing that we're going to do. Permit me to write it up here. Since we have sine alpha cos beta plus cos alpha sine beta, which is equal to sine alpha plus beta in bracket, we're going to now write sine in bracket alpha plus beta. This is a sum and difference identity which you need to know, and it's really important whenever you are proving trigonometric identities or simplifying trig expressions. And for the denominator here, if you have cos alpha cos beta minus sine alpha sine beta, this identity is equal to cos alpha plus beta. This is also a sum and difference identity which you should know. So this expression here, cos alpha cos beta minus sine alpha sine beta, is equal to cos alpha in bracket plus beta. It's a sum and difference identity which you should know. We have Pythagorean identities, quotient identities, reciprocal identities, sum and difference formula or identity. We also have half angle formulas and double angle formulas. These are things that you should know. So all this expression on the numerator simplifies to sine alpha plus beta, while everything on the denominator simplifies to cos alpha plus beta. Therefore, this is now going to be sine alpha plus beta over cos alpha plus beta. And at this juncture, we should remember that sine theta or sine alpha plus beta or anything or sine A or sine B over cos theta is equal to tan theta. Therefore, this is now going to give us sine over cos gives us a tan. Therefore, we're going to obtain tan alpha plus beta. This is what we're looking for, and we have proved that the right part is equal to the left. We started with the right and ended up with the left as we have here. Now let's go ahead and solve the second problem. Like we did for the first one, we're going to start from the more complicated part and end up on the easier part. And like I said also earlier, we're going to convert this tan into sine and cos because it's easier to work with cosine and sine than with secant, cosecant, or tan. Remember that tan alpha is equal to sine alpha over cos alpha. We're writing this expression because it's easier to manipulate sine and cosine than other identities or expressions. All right, so I'm going to write my proof. RHS, which stands for right hand side. And I'll copy this down again and start from there. We have tan alpha minus tan beta over 1 plus tan alpha times tan beta. Since tan alpha is equal to sine alpha over cosine alpha, I'm going to replace tan alpha with this value. And I'm also going to do the same for tan beta, where tan beta will be equal to sine beta over cos beta. This is going to be sine alpha over cos alpha minus sine beta over cos beta. We're done with the numerator. Let's now convert the denominator. Here we have 1 plus. Our tan alpha will now become sine alpha over cos alpha multiplying, because these are multiplying themselves. We'll put a dot sign here to indicate multiplication. Multiplying sine beta over cos beta. We are writing everything into sine and cosine because it's easy to manipulate sine and cosine than other expressions or identities. Now, just like we did for the first one, let's combine this into a single fraction and this as well into a single fraction. And how do we do that? I'm going to draw a small line here so that we can use a space. And here we have numerator. This is going to be sine alpha over cos alpha minus sine beta over cos beta. I'm going to use this space now to simplify this numerator. Remember, I told us that we're going to multiply everything on the left by the denominator of the right and everything on the right by the denominator of the left. It's as simple as that. Just multiply diagonally and diagonally. Everything here we multiply by what we have on the denominator of the right, and everything on the right we multiply by the denominator of the left. Let's do that. Cos beta multiplied by sine alpha will give us sine alpha cos beta, and cos beta times cos alpha would give us, this is over, cos alpha cos beta minus cos alpha times sine beta would give us sine alpha, or sine beta rather, cos alpha over cos alpha times cos beta will give us cos alpha cos beta. Now they have a common denominator and it's going to be quite easy to combine them right now. Okay, therefore we're going to have sine alpha cos beta. Permit me to put the cos alpha first. Multiplication is commutative. It doesn't matter whether you say 2 times 4 or 4 times 2. So since multiplication is commutative, we can put the cos first and the sine after. This is now going to be minus cos alpha sine beta over the denominator, which is cos alpha cos beta. We're now done with transforming this numerator into a single fraction. We're also going to do the same for the denominator, just as we did in the first video. Therefore, this is now going to be, this is our denominator. Let me copy all this down. We have 1 plus, permit me to do the multiplication here. Sine alpha times sine beta is going to give us sine alpha sine beta over cos alpha cos beta will give us cos alpha cos beta. Remember that this is 1 over 1, 1 over 1. I added the over 1 for simplicity's sake, because 1 divided by 1 is also 1, so we have not changed anything yet. Now let's combine this as a single fraction by multiplying across. Cos alpha cos beta times 1 will give us cos alpha cos beta. Cos alpha cos beta again multiplied by 1 will give us the same value. We have cos alpha cos beta plus, the next one is to multiply everything on the right by the denominator of the left. 1 times sine alpha sine beta will give us sine alpha sine beta over 1 times cos alpha cos beta will give us cos alpha cos beta. They are the same, and at this point we can go ahead and combine them as a single fraction. Therefore, we shall obtain cos alpha cos beta plus sine alpha sine beta all over cos alpha cos beta. All right, we have combined them as a single fraction. Here we have our numerator and this is our denominator. Therefore, we can now go ahead and divide them. I'm going to clean this part and work on it or work on them here. Let me combine the two fractions together. Here we have sine alpha, this is the numerator as we have over there, cos beta minus cos alpha sine beta over cos alpha cos beta divided by, just as we did for the first one. Now we're going to write our denominator here. Since they're dividing, this is our denominator. We shall now obtain cos alpha cos beta plus sine alpha sine beta sine alpha sine beta over cos alpha cos beta. What's the next thing to do at this point? We're going to take the reciprocal of the one on the right and change the sign from division to multiplication. Writing this expression, we're going to have sine alpha cos beta minus cos alpha sine beta over cos alpha cos beta. Now we change the sign from division to multiplication and the denominator becomes the numerator, while the numerator becomes the denominator. We have cos alpha cos beta over the numerator, which is cos alpha cos beta plus sine alpha sine beta. At this point, we can now cancel out this. This and this are the same, so they can easily cancel out. They can cancel out, and when they cancel out, what do we have left? We're left with, we have a 1 here, and here we have a 1. Okay, please permit me, my pen is not writing properly. We have a 1 here and a 1 here. So this multiplied by 1 gives us the same value, and this one on the right multiplied by 1 is also going to give us the same value. Therefore, we can copy them up here and simplify. We have sine alpha cos beta minus cos alpha sine beta. Sine alpha cos beta minus cos alpha sine beta all over the denominator here, which is cos alpha cos beta plus sine alpha sine beta. All right, now what's the next thing to do at this point? Just like we did for the same for the first question which we solved, if you have this identity sine alpha cos beta minus cos alpha sine beta. This is a sum and difference identity. And sine alpha cos beta minus sine alpha cos alpha sine beta is equal to sine alpha minus beta. This is a sum and difference identity. I told us initially that in order to succeed in proving identities or trigonometric expressions, we must have all this by heart. Reciprocal identities, sum and difference formulas, double angle formulas, and whatever you have, you must have them at heart so that it will be easy for you to recognize a pattern and relate it to an identity which can help you simplify whatever expression you have before you. Therefore, since this is equal to this, we're now going to replace the numerator with sine alpha minus beta. We have sine alpha minus beta over the denominator is also an identity. And what is that identity? If you have cos alpha cos beta plus sine alpha sine beta, this is also a sum and difference identity which is equal to cos alpha minus beta. For the cosine sum and difference identity, if you have a plus here, right, it is equal to a minus in bracket. And if you have a minus at the center, it's equal to a plus in the bracket. This is the sum and difference identity. And this is what you are supposed to know as a student who is studying trigonometry. With these identities, we can now replace the numerator and denominator with these values respectively to get what we want. Since we have replaced the numerator with its respective value or its equivalent, we're now going to replace the denominator with cos alpha minus beta. Cos alpha minus beta. And we know that if we have sine theta over cos theta, this is equal to tan theta. This is also another identity which is called a quotient identity. And we've seen that we have sine over cos. This is now equal to tan alpha minus beta. And this is what we are looking for. It's as simple as that. And I hope you've understood it. If you've not, try to watch it over and over again, and you'll definitely enhance your skills in trigonometry. Thank you for sticking around till this time. See you in the next video.